Okay, this is where we were last. You remember this. We talked about BDD, behavior-driven development. The whole point of this presentation, though it may be technical for some of you, and I don't want to scare any of you off, but I'm looking at the numbers, so I might have scared some folks off. Today is as technical we will get not as technical in the future. Basically, all I want us to understand is that we cannot inspect quality into our products that we're building. You have to build it in. It's a systemic thing. We're going to talk a lot about systems and systems theory and systems, why it's important in complex systems, et cetera, but you have to build it in. So I'm going to give you an example of how we build it in with software development. Now you're going to have other ways that you're going to build it in with whatever you're doing if it's not software development, though I know I'm looking at the number of participants. There's 92 participants. I would say that more than probably about 3/4 are probably in technology. So this will make sense to you. Some of you won't make as much sense. You're smart people. You need to translate it into what you're doing and say, ask yourself the question, how do I build quality into what I'm doing? Because inspection won't do it. So why do BDD? We talked about it last time. To me, this is as close as you're going to get to a silver bullet in software development, because it does what we need it to do in terms of building the right things. And it leads us into test-driven development so that we can build it right. So it covers both of the sides. That's all you need to do to be successful, optimal. Sounds real simple, doesn't it? I used to tell people when I own my own business, owning your own business is pretty simple. In the end, you just got to make more money than you spend, right? It's kind of one of those things. Let's boil it down to it. You got to pick the right things to do, and then you got to do them as perfectly as possible. One of them is, choosing what to do. The other is process. BDD allows us to bridge those things, both of those things, so that we have this common language with the business, so we make sure that we're building the right things, because a lot of times business will say one thing and we'll hear another thing, right? Or sometimes developers will say one thing and the business will hear another thing. So if we can't communicate, how are we going to build good products? It happens so frequently. This is such a simple and elegant solution. I wrote a blog, 10 reasons why BDD changes everything. That's where we finished last time, because I didn't have the time to go through all 10 of them. I might have, but I wanted to make sure. The number one thing is communication. Day one, what do we say? Complex world feedback. What is feedback? It's mostly communication. What is that? That's people talking to each other. I mean, it could be text and email and other things, but it's usually people talking to each other, and people talking to each other in front of a whiteboard or some place where you can write down some ideas, scribble some things out. That's the best type of communication you can have. And when you have good feedback, you tend to do better in a complex system. When you have poor feedback, complex systems can go in all kinds of strange directions. We've seen that time and time again with our complex financial system here just in the United States. These are bubbles and other things, right? I was pretty well affected, as a lot of us were, about, what was it, about 12 years ago now, with the collapse of banking. That's what happens in a complex system when you remove feedback, or in this case, you have fraud, which is basically intentional poor feedback, by basically saying that these bonds are A++ rated or AAA rated when they were junk bonds, and people were buying them, and then people defaulted, and it caused a collapse of the entire world's economic system, or at least very close to it. So communication and feedback is the key, and this is where BDD helps us. We also are able to take the business needs, wants, and desires and tie that into the product or the code that we're writing. And that's traceability. That is the holy grail of software development, as far as software product development. I need to be able to trace my needs directly to the code that is written. We know what tests we write as a minimum for test-driven development, because test-driven development is a good thing. We talked about that before. You don't have to believe me, believe the experts on that one. That's why I presented Uncle Bob Martin. once we start doing test-driven development, because we weren't probably doing it, when you get the test-driven development, you can start actually doing it, because I was talking to some developers in the last one, and they kept saying, yeah, we know test-driven development is a good thing. And I asked them, do you do it? And the answer is, we really don't. So if we can start making test-driven development easier and they start doing it, we're going to get all those benefits that we talked about for test-driven development. Your code becomes much, much easier to maintain. And that's the key. Because when you look at the software development life cycle, the product development life cycle of software, most of the product development cycle is making enhancements on existing code. It's generally about 70 to 80% is what I've seen as the numbers that people publish. I think it's more than that, because I think I've told you the stories of software generally doesn't go away. I was hired by a company to sunset their software product years and years ago. They gave me, I forget, it was 6 months to a year to sunset the product. We got bought out. Company keeps the product. They kept it going. I lost the job a decade ago. The software is still going. It's like the poor. It's always with you, right? Isn't that what they said in the Bible? The poor is always with you. So is your code. I would say you're probably going to spend 90% of your time enhancing it. In fact, when I work with people on their backlog, a software development backlog, I tell them that every one of these things on your backlog, you can call them stories if you want to, I call them enhancements. Because as soon as you write one line of code, everything you're doing is enhancing that line of code. If you're fixing a defect, you're enhancing the code. If you're paying down technical debt, which we're going to talk about later today, if I get to it and I don't go off on the rails too much, you're improving or enhancing the software. If you add a new feature, you're enhancing the software. We think about new features as the only enhancements to software, but generally speaking, most features in software are rarely, seldom, or never used. It's about 80% of all features in software are rarely, seldom, or never used, but we put them in anyway. I don't know why. Would be much better just to pick the 20% that people actually use and care about and then make them much, much better, as opposed to continuing to have buggy software and delivering more features on top of it. Your code is self-documenting. You're going to see this as we go through it. We're going to write things in human readable English, because this is something that business folks have to understand. We're not going to write things in code. When you write tests, like test-driven development, you are documenting your code, because you're writing in code what your code does, if that makes sense. So when we used to hire people, when I used to be a software development manager and director, and they actually had people reporting to me, which was probably irresponsible, but they did anyway. When we had to bring in new people, we never did a very good job onboarding, and I don't think any company really does. They always complain about it, but they don't. What we did is we'd say, you get a new developer, here, read the code. If anybody's tried to read code, that's not easy. So if you have a bunch of tests, it becomes easier, because you say, hey, read the tests, because the tests are going to tell you what the code does, if that makes sense. What we're going to do is and documentation always came last, right? In Scottsdale, Arizona, I don't know if you're familiar with Scottsdale, Arizona, we used to have this thing called the Parada del Sol. That was my favorite day of the year, because it was the world's largest horse-drawn parade. And at the end of the parade, they had these people with shovels, obviously. That's how I felt when I was in documentation and training, right? Because we were always the last. But that's what happens. So you can't really trust your documentation, and your training generally doesn't keep up with the software. That's always problematic. With behavior-driven development, it's the opposite, because what you're actually doing is you're writing the documentation of the system before you start writing the code. So your documentation is always up to date, as opposed to what usually happens, because what we're going to do is we're going to write self-documenting stuff. The stories are easier to refine. I did finally change this, because the word is refined. Some of you folks might have heard the word groom. I got rid of that about 7 years ago. That's always a brown, a brown M&M to me when people use the word groom. I'll explain that in a second, but it's easier to refine the stories, because what we're doing is we're putting together it's scenario based. For those of you who've done use cases before, it's like use cases. And we know how big the work is by the number of scenarios we write. And some scenarios are going to look more like other scenarios. So if we start doing this refinement and we find out we've got a bunch of scenarios, it gives us places where we might be able to break off pieces. So it makes it easier to refine. And that's what we're talking about here is we're talking about using BDD as acceptance criteria during story refinement. So the brown M&M story. Some of you are familiar with a rock group called Van Halen. Van Halen used to have they have these big contracts that are like this big when they go to a venue, right? Because these are pretty big shows and they have, pyrotechnics and everything like that. You remember Michael Jackson got caught on fire. These are things where people can get hurt if they don't do the rigging correctly. So what Van Halen used to do, and everybody thought they were just divas, is they had a line in their contract, a writer in their contract that said there will be no brown M&M. You need a bowl of M&Ms in the green room or whatever. There will be no brown M&Ms in the green room. What this was for them is this was their signal that the people read the contract, because they knew if they go into the green room and there's brown M&Ms that they probably didn't read some of the other things that were actually important. And they canceled the show, because if they didn't read the parts about all the other things that they needed to be safe, then how if they can't do this, how can they do the other stuff that's important, right? So anytime so don't do this. At least if I'm interviewing you for a Scrum Master, don't use the word groom anymore. It's a brown M&M for me. I'm not going to hire you. The word is refine. There's other brown M&Ms that I have when I'm in interviews with Scrum Masters and they tell me certain things. Teams can be more agile when we do this because we can break things down. Obviously, agility is important because we want to deliver the most value we can over the shortest period of time. This helps us to ensure that the things that we're doing are valuable and small, et cetera, et cetera. As I said before, the developers can be onboarded easier. That's a big deal, by the way. If you look at, not LinkedIn, who is a Glassdoor? You're all familiar with Glassdoor because you're looking for work, right? So somebody from some random company sends you an email message, and the first thing you do, hopefully, is you look them up on Glassdoor and you see what people had to say about them, right? And what they do is they take all these reviews of companies from employees and former employees, and they put them together and they say, here are the top 10 places that you can work at, right? And we all know them. Almost all of them are represented, for us lucky folks in the Bay Area, they're represented in the Bay Area. It's your Googles and your Facebook. It used to be Facebook. I don't know Facebook anymore, but Google and others, right? These are the best places you can go if you're a developer, supposedly. The best. I'll put it in quotes. You know how long the average developer lasts at these places? 2 years or less. I worked at one place where they told me, one, because they didn't do a good job they should have been doing BDD and they didn't do a good job of onboarding their people anyway. They said it will take 6 months for a developer to become productive in our system, which would be 25% of their normal tenure is spent just getting them up to speed. So there's a huge benefit to getting developers up to speed as quickly as possible. So if you have self-documenting code, it's much easier for me to give you an understanding of what the code is doing if I follow this BDD/TDD process, right? That's amazing to me, by the way, that the average tenure is about 2 years, even at the best companies. Because I don't think, honestly, I've worked at a lot of different companies, and some of the ones that are considered the best companies, and I didn't think they were the best companies. They may have massages on Thursday, and they may have a ping pong table or something. That's another brown M&M for me. When I go on a tour of a company and they show me the foosball table. Yeah, we take care of our people. We gave them a foosball table. I know some people want foosball. I mean, if you have a company that's bad and a company that's just as bad, and then the just as bad company has a foosball table, I might choose that one as some kind of differentiating thing. But you know what knowledge workers really want to do? Their job. I want to go to a company that says, look, these people are happy because they're doing their job. They're engaged because we allow them to do their work. Not, we don't really care that much, but here's a foosball table if you're not engaged, because every once in a while you can go, goof off. Aren't we great? Give us a gold star. There's a reason companies don't let me run companies, I think. There's more visibility into team progress and status if you do this, because everything becomes fully transparent. Those were the 10 things. There's more things. This is just a great thing. I mean, you know, I'm willing to admit that I could be wrong about this one, but I don't think so. This is a good thing to do. So how does BDD fit into this wonderful thing called TDD? Well, TDD is here, and BDD provides the input into the TDD process. That's it. It sits outside of it. I'll show you how in a second. But first, how many people have done sales before? Anybody? I know we had some salespeople in there. Raise your hand. What do they tell you? They say, sell the sizzle, not the steak, right? No, never heard that one. Basically, sell all the benefits first before you tell people what it is, right? So I'm going to do that. I'm going to tell you, here are the success stories of when, these are just a few of the success stories of when I have worked with teams to apply BDD to what they're doing and the results from it. The first one I told you about was when I didn't know about it, and somebody in a retrospective told me about it. And I didn't, as I said before, I didn't really understand it. I just said, you know, you think it's a good thing to do. It's your team. I'm a scrum master. I'm not the one who's responsible for the work. You go ahead and do it. But I didn't really understand it. And then a couple of years later, I'm in a new place, and we're going through this process of trying to refine the work, understand the work, the stuff that's on our backlog. And it was awful. It was just awful. They were just coming out of a waterfall environment anyway. So what they were trying to do is they were trying to do the waterfall type, you know, requirements docs and call them stories. And it was, I always say it was like pulling teeth. So what we did is I said, hey, there was this one thing that I did before. I didn't really understand it before, but it seemed to work really well. So I actually studied it. This is when I finally learned about BDD, because I finally had to figure it out because I needed it. And so I studied it, I figured it out, right? I said, we need to do this. And once we started doing this, at the time, we had business analysts working as the product owner. And she got through so many stories by using these scenarios and doing it this way, that I had to tell her to slow down, because she was actually doing too much work. Because we're just in time here in the agile world. She was getting too far down the backlog. Slow down. So we went from not being able to do anything to, it was just like a dam burst, right? It's like it was cloudy, and then all of a sudden the sky parted and the sun shone, and that's what happens when we learn something. We get that aha moment. In fact, that's what I usually tell people in my job interview. That's my job, is to give people that aha moment where things start to click. Anybody know what this picture is on the right? That's the Alamo. Remember that. That's my joke. It's not really a good joke, but anyway. I was down at a financial services company in San Antonio, Texas. Great team. I worked with their innovation team. See, I told you I always get lucky. I get to work with some of the great programmers and things. It was an innovation team. Their job was to take things from proof of concept and get them into customers' hands as quickly as possible, because they were an old waterfall shop too. And when they had new product development, it usually took them about a year or more on the average from a proof of concept into their customers' hands. What we were tasked to do was to cut that time down, to get a minimum viable product into the customer's hands within 3 months or less, which is way beyond anything that they've ever done. They had this wonderful product, by the way, because they worked with a lot of military folks. And in the military, one of the things is that, and they had a bank, right? So they wouldn't take checks. I don't know if any of you folks been in the military, but a lot of places that are around military bases won't take checks because you're very mobile. So I guess a lot of landlords got stiffed. So they want a cashier's check. So what would happen at this particular bank is that at the beginning and the end of the month, when the rent was due, they'd have lines out the door of usually women whose husbands were on deployment, who were getting these checks. And they said, this is terrible customer service. We can do better than that. So this was really early on when cell phones, smartphones started being a thing. They said, hey, you know what we can do is we know how much money they got in their account. Let them request it on a smartphone. We'll give them one of those fancy QR codes. And all they need to do is show that QR code to a kiosk and it'll print the check out because we know they have the money. Pretty cool product. We took that from the concept to our customers in the first branch in less than 3 months, something they've never done before. Much, much faster than anything they've ever done. This is a huge success story, in part because of BDD. And I'll tell you why. There's a couple instances where this came into play. One is with BDD, you're writing the tests first. So one of the things that we had to do is we had to interact with SAP. I think it was SAP. It was a third-party system that handled financial stuff. If it wasn't SAP, it was somebody else, right? And we had to send them certain information. They would send us back certain information, classic API thing. So what we did is we knew this ahead of time. We wrote tests for their work, meaning we know that we're going to send you these 5 things or whatever it is, and you're going to send us back these 3 things. And we knew what they should be. And we wrote a test for it. And what that allowed us to do is it allowed us to send that information to the vendor, who we had no control over, really, and have them do their work pretty much in isolation. What we did is it allowed us to mock out everything that the vendor was supposed to do because we just assumed that at a certain point in time they would send us this. So we acted like they did. That's what mocking is. And then we had a test. So when they finally sent us what they did and we integrated it, we ran that test. And 5 minutes after they sent us whatever they sent us, I think it was, at this time, it was just a simple jar file. If anybody's familiar with that, it's just one file. They sent us a file, we ran it, and it broke. It didn't work. The test didn't work. This is huge. Because not only when the test doesn't work do we know exactly what they didn't do that they should have done. So we picked up the phone, literally picked up the phone, called the people and said, look, you got a problem. And you know what their first response was? You all are veterans. You know what their first response was. It's not our problem. It's your problem. I've seen some of these, some of them have the derogative term, something contest. I've seen these contests go on for a long period of time, back and forth, people pointing fingers at each other. When you have tests and you have BDD, this doesn't become a problem because all we did was say, no, we've got a test. We know exactly where you did not conform to our specifications. We'll send you it. We'll send you the results of the test. And we did. And guess how quickly they were able to fix the problem? Right? So instead of waiting 30 days for us pointing fingers at back and forth with each other, trying to figure out whose code was at fault, we knew immediately, and they fixed it within 24 hours. That's one of the reasons we were able to deliver ahead of the 3-month schedule. Not within the 3 months, ahead of schedule, because we were doing this. It was so successful that the developers who did it went on what I called the BDD World Tour. They went on their own. I supported them, obviously. I was very proud of them. They went on and they went throughout the whole enterprise there, and they taught as many people about this as they could. And I was always there in the background just gloating. And what they used to say is, yeah, we were tempted at times not to follow the process because it seemed like it was slowing us down. But every time we didn't follow the process, it bit us in the butt. It caused us problems and it ended up costing us more time. See, this is the benefit of building quality in. So not only did they go on their BDD World Tour, but management paid attention too, because management, and when I use management instead of leadership, I'm not going to say the best things. Because management wanted to get everybody together who worked on the project and then talk about why this project was successful. That's how good it was. And I'm not talking just directors, you had VPs and senior VPs, right? And we all get in a room. Oh, by the way, I wasn't going to be in the room. I think I had a big part to play in this, as much as anybody else on the team, because we were a true team. I was a contractor, so I wasn't going to be invited. But the team members were real nice, and they said, no, you got to invite Larry because he was part of this too. So that was kind of interesting. And then, and I always tell this, they asked a question. They said, this is just like a bunch of people working in a garage, because it kind of was, because they actually stuck us in the basement. If you're gonna do an innovation project, you need to be in the basement or another building. You need to be far from the clutches of the evil empire that spawned you. They said, how do we replicate this? How do we scale this? And anybody who tells me, how do we scale this? You know, this is what I hear from now on, and maybe this is my bias. It's not a real question. I was naive back then. This is some years ago. I thought they wanted a real answer to the question. They don't want an answer to the question. What they're saying is this won't scale. That's what they're saying. What I'm hearing is, I don't know how this will scale, or scaling this will actually be a threat to me in my management job, or it may be too much work for me as a manager. That's what I'm hearing. But I was naive enough. I said, we'll just build more garages. That's the answer. Build more garages. What were the garages? Build, independent, effective product development teams using Scrum teams. That was our garage. We just followed Scrum and Agile, and we could have done anything, but we were very successful. Okay. You get the picture. You see how much I like management sometimes. The ultimate irony is if somebody puts me back in management and I become a manager instead of a leader that I would hope to be. 3 simple steps to adopt BDD. First one you can do today. So if you have a job today, or the first day you get a job, you can do it on the first day, I think. Step 1. When you're doing story refinement, because I'm hoping that you're doing Agile and Scrum and that you've set up a cadence, and that part of your cadence is making sure that you're refining the stories at the top of the backlog. All you need to do is a very simple change. Just write your acceptance criteria using BDD scenarios. That's it, nothing more. Change the way we talk about the work. There's very few companies, I don't think, who's going to say, oh, we don't want you to write your acceptance criteria this way. I have run into one, but I won't even go into that one. I'm still bitter after all these years. But usually they're not going to tell you how to write acceptance criteria. They're just going to be happy that you actually are doing it. So you can do this tomorrow. Just talk about it differently. That's it. And that's where the big benefit from it comes, because what is the key in the complex world? Feedback, communication. We think it's something else. We're going to talk a lot about biases, but this one has come to mind so often lately. I'm just going to throw this one out here because it's going to tickle my brain, and then I'll be distracted for the rest of the class. There's something called proportionality bias, meaning that if I have a really, really big problem that I need a really, really big solution, but that's not how the complex world works. If you're really, really smart, you'll understand that in the complex world, sometimes we can make some very, very small changes. And because of nonlinearity, which I talked about on day 1, the fact that the input and the output are not linear, you can actually solve some very, very complex problems with some very, very simple solutions. But we're always looking for complex solutions to complex problems. That's not the way the world works, though. In the physical world, yes, right? If I need to move a 1,000-pound bridge or something, I'm not going to be able to do that with one human being. There's a proportionality in the physical world, but I've talked about that too. But there's a proportionality in the simple and the complicated world that doesn't exist in the complex world. So the very simplest thing of just talking about the work differently and communicating at the same level creates so much benefit that I get all excited about it, right? And I spend a whole day talking about it. Step 2. Once we have written these BDD scenarios in human readable English, we've changed ever so slightly the way we talk about the work. We can take these BDD scenarios and use them to actually create tests and do test-first development, test-driven development. Step 3, there are some tools that will help us. I was naive at the beginning. I'm naive about a lot of things. My wife reminds me all the time. She's good at that. And she's right. But I was naive about this one too. I thought that you had to do them in the other order. That's why I want to make very clear. Don't wait for the tool. The tool will not save you. It's people and interactions, not processes and tools. We said that on day one, right? So the step one is sometimes referred to as the three amigos. You're going to have somebody usually a quality person on your team. You're going to have a developer and you're going to have a product owner. Those are referred to, somebody, you might see it somewhere, as the three amigos. Generally, you need these three people together. Why? The product owner has the business knowledge. The quality person, and they don't have to have QA in their title. They just have to be somebody who's concentrating on quality, which is a different way of thinking. It's very easy to sum up this. Developers make things, QA people break things. It's a different mindset. The QA people are going to be your what about people. They're going to say, okay, you've given us this happy path scenario of what will happen in a perfect world. What can go wrong? And then you're going to write scenarios about that. And I'll show you in a second. It's very important you have quality mindset. This is where you get the most benefit, just talking about things differently. I know it sounds strange because some of you are saying, what? We could just talk about things differently and the whole world's going to get much, much better. Yeah. Here, finally getting to it. Here's the steak. I sold you the sizzle. Now I'm going to sell you the steak. Everybody knows what an ATM, automated teller machine, is. We take it for granted now. In fact, we don't even probably use them anymore because we're just using our smartphones. That's okay. I remember when they were new. What a nice concept. I can just put in a card and type in 4 digits and I can request my money and it's going to give it to me. And I don't have to go and wait in line at the teller at the bank. Wow, that's great. So here's the story. This is the happy path, right? I'm going to withdraw cash. Now, remember before I talked about when we're breaking this story down, we're going to break it into a narrative, acceptance criteria, and potentially tasks and hours. Here's the narrative. Many of you are already familiar with this. This is not something obviously that's in the Scrum guide. You don't have to do this, but it's a good practice. As I want, so that. We're talking about in the narrative, who, what, and why. These are 3 important things. As a customer, I want to withdraw cash from an ATM so that I don't have to wait in line in the bank, right? And this passes, as I'm going to refer to it as the Gale Apke test. That's my mother. She's not very technically inclined. If my mother could understand it, it's probably a good narrative. She can understand this. She's a wonderful woman. She's not technical. Don't have to be. It's not about technology. It's about solving a problem. What's the most important part of the story narrative? It's actually the last line. The last line is why. And as I told you on day one, the very first thing is why is the most important thing, because sometimes you get to a refinement discussion. That's what you're going to do, right? I'm expecting that the product owner is going to be writing this narrative and bringing it to the refinement session. And now that I know they don't want to wait in line at the bank, maybe I come up with a different solution. Maybe together we come up with a different solution. We come up with a different what. The second most important thing is who. We have to keep reminding ourselves continually that we're actually doing this for someone. And we need to understand and empathize with that person. Now, this isn't a great who, because it's just as a customer. It's not very descriptive. There are some places that get very descriptive. I worked at one place that they had what's called personas of people who use their software, and that was great. And they had life-size cardboard cutouts. And they placed them in the room. It's kind of creepy when you're there late at night by yourself. Who is important, because we need to continue to remind ourselves is who is going to benefit from what we do and why they're going to benefit. The least important stuff is the what. This is the thing, and I'm always slamming on waterfall, but just occupational hazard. Waterfall tended to emphasize the what, and that was it. Waterfall tend to emphasize, here's what you do, just go do it. Why? Because I told you so. Right? So that is what I would call the customer narrative, because everybody uses it. I've never seen anybody call it anything. So if you see people keep referring to it as narrative, then great. You probably, that's cool. I think I invented that. If somebody else knows what it's called, I'll start using that one, but nobody's helped me yet. The most important, there are times you can write it differently. You don't have to write it like this. But this is what most teams do. So a lot of times I don't want to swim, upstream. I always tell my kids, you got to choose which hill you're going to die on. So ultimately, if I could get a team to do it, I would flip the order. I would do why, who, and what, because that's the order of importance. I would say in order to not wait in line at a bank, as a customer, I want. And some people do that. It's better because it puts it in the correct order. Anyway, enough said on that. That's the narrative. For each one of these, we're going to have different scenarios. So I got a bunch of veterans I can see on my screen. You probably remember something that we used to call use cases. It's pretty much the same thing. We're going to call them scenarios now. And we're going to use specific language. There's certain keywords that we wish to use, and I'll go over those keywords. This is so simple. This is the happy path scenario. You actually are going to go to the ATM and get money, and you actually have money in your account, right? This is something also when I expect the story narrative to be written by the product owner, I expect usually 1 or 2 happy path scenarios to be written by the product owner before we even get into the refinement, because they should know this. If they don't know this, well, how can they ask for for the change? Given is the first keyword. What are our givens? What are our prerequisites? What is special about this particular scenario that is different, potentially different from any other scenario? This is where QA helps us, that mindset, because the QA folks or the QA mindset is going to look at all kinds of different potential scenarios. And the thing that changes the most is the given. Where are we? What are we doing? How is the system? Given the account is in credit and the card is valid, and so the and is another keyword, right? And the dispenser contains cash. That is a clause, a given clause, right? These are 3 things that are important to this particular scenario. I'm going to make a change. This is the behavior part. I'm going to do some kind of behavior when the customer requests cash. So my second key, my next major keyword is when. When is basically, it's like an experiment. We're only changing one variable. In this case, we're only doing one thing. If you have when this and this, then you've got 2 different scenarios. It's very rare that you have a when followed by an and, right? Because you're doing 2 things. You need to test each one of those separately. When the customer requests cash, and here's the last major keyword, then. Given when then. Then ensure the account is debited. Make sure that you take money out of their account because they're going to grab some cash. And if you don't take it out of your account, then it's going to be problematic. That's free money. That's cool. Ensure the cash is dispensed. That would be good. You don't want to take money out of their account and not actually give them money. That's good for the bank. And then give them the card back, right? We've all done these transactions before. This is, again, passes the Gale Apke test. My mother could understand this scenario. You'll notice that the when part is generally the QA folks, the QA mindset. The then part is the business. Given this and this and this, when I do this, hello business, what do you expect to have happen? Right? This is the quote unquote functionality of the system. Very, very simple. Here's the thing about this. When I have this conversation, assuming that I have developers who are writing, financial software, I could ask a very simple question as a Scrum Master as we're going through this refinement process. Do you understand the narrative? Do you understand this scenario? Do you have any questions about this scenario? Because we will then talk about this particular scenario and we will make any adjustments that need to be made. But when we get to the end of it, I'm going to ask a very simple question of my developers. If I asked you to write a failing test for this behavior, could you do it? Because that's the TDD part, right? In TDD, we write a failing test first. And I asked them a very simple question. Can you code that? Could you code a failing test for the scenario? If the answer is yes, that scenario is good. We move on to the next one. The interesting thing about this, and I've done this many times, is that these write themselves. After you write this happy path scenario, I can write a few scenarios just based on that without knowing anything about it. And I've done this before. I've played this game before. I worked at one company where I had no idea what their software really did. And I didn't have the time or inclination to actually learn because that's not my job. I'm a scrum master. I'm a facilitator. But when we went into refinement sessions, they would give me a scenario. And as soon as they gave me the first scenario, I would say, now hold on, guys, I'm going to show you a trick. I'm going to tell you what the next scenario could be. And you tell me if I'm wrong. Because what does this say? It says, given the account is in credit. Guess what? I got another scenario for you. Given the account is not in credit. Given the account is in credit and the card is valid. I've got another scenario for you. Given the account is in credit and the card is not valid. Right? You with me? They write themselves now, if you're thinking like a test person. So let's do another one. I don't have the money. That's the second one that comes to mind. Given the account is overdrawn and the card is valid, I didn't need the other one, right? So I'm writing this. When the customer requests cash, same behavior, different scenario. What do? Give them a rejection message, can't give them the money. Don't give them the money, give them the card back. Now I could easily say to the business, is this what you want to do? Is this a behavior you want to see as a result of the behavior of the customer, right? In the scenario, this particular scenario. Business could come up with a completely different scenario. They could say, okay, give them a rejection message, keep the card. Because the rejection message says, come into the branch, we need to talk, you deadbeat. Right? It could be that. That's where the then becomes the business part. What do you wish us to do? Something has changed in the system. What is the resultant change? And you can see how it's like an experiment in the sense that we're changing one variable based on a certain environment, the given. What do we want to do? Very simple behavioral stuff. And everybody understands it. This passes the Gale-Apke test. Gale-Apke can understand this. And I can go back to my developers and say, could you write a failing test for this? My developers would say, yes, I can. And I'd say, that's a good scenario. Let's move on to the next one. And we would identify one after another, all the scenarios that would be important to that story. And here's the fun thing, as I was saying before, if we identify, you might have 5, 6 scenarios. That's good. That's probably what you would do, right? So that's probably tight enough in terms of functionality. If you're writing 12 scenarios, there's probably a couple scenarios that look more like the other scenarios, and I could break the work. I can split it into smaller pieces, one having more value than the other and one that I should do before the others, because once I split a story into 2, I need to look at the value and effort of those stories, right? And sequence them. So for those people who talk about how do we split a story, this is one of the easiest ways that you can do to split a story. There's other things you can do. I've got a story that's too big. How do I want to split it? Well, tell me all the scenarios. Let's find the ones that look more like another. Let's group those together, give it a different story narrative, and it's a different line item in our backlog, and let's revalue, re-effort, resequence. You with me? Some people nodding your heads, so good. We want to leverage these now. What we've written is a test. In human readable language, you've written a test. That's all a test is. And I know this, not only because I've been doing it, but if you think about a defect, if you're doing software development, when somebody tells me there's a defect, you know how they describe it? I was on this page and I had blah, 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 and I had blah, blah, blah. And when I did this, then I expected to see this, but I saw this instead. That's the only difference between this and a defect. In the defect, they give you the same information, say, I expected to see this, but I didn't. I saw this instead. Right? So that's beneficial too, because one of the things about BDD is if I run into a defect and I'm going to fix it, I just rewrite the scenario the way it should be. Right? And then I write a test for that scenario. Then I fix the defect, because now the defect will remain fixed because I have a test for it. That defect will never show up again. shouldn't show up again because I'm running a test. And if that test fails, then I've created that same defect again. If the test doesn't fail, I've actually fixed the defect. I've shot the zombie in the head. Because that's one of the things, a lot of times when we're working on defects, it's like playing whack-a-mole. We fix one defect and create two others. You see how this very simple strategy has such a huge, huge benefit? Sometimes convincing people of this is like pulling teeth, though. I'm not going to get too much into code. This is the only time you'll see some code briefly for those who might understand it. Don't let it freak you out. This is some pseudo Java code. This I learned from my friends down in San Antonio, by the way, because I thought we always had to, have a tool, but they said, no, we can't get a tool because it's like getting a blessing from the Pope. It'll cost a lot of money. It'll take a long time, that kind of thing. So all we're going to do is we're going to actually write. So when you're writing code, you can put comments in the code. I think even people who don't know code know that. You can put these scenarios in the comments of the code. So when I go back to read the code later, I can see why I've written the test. And I've documented the system in human readable English. So what I've done here is I've just taken the same thing and I've shown you, with a / as a comment. I've taken the actual scenario and put it into the comments of a test. But the interesting thing about this is test-driven development. It's also something referred to as test-driven design because the tests are actually helping you design the architecture of the system. Because I'm writing a test before I'm doing anything else. So for those of you who don't know code, if you want to, blink out for about 5 minutes, I'm going to get a little deep in here for the people who do. You'll notice that because of the scenario that I've written in human readable English, I know what to call my test because I'm going to call it the test account is in credit test. So it's actually designing the system, right? And you'll see that I know that I have something called customer request cache, and that's going to be a method. And what am I going to pass to it? I'm going to pass to it the amount of cache, right? So you see the word amount. So it's actually helping me build the objects in my object-oriented programming, and it's telling me the methods on those objects that I'm going to need. I haven't written any of those methods. I haven't written any of those production code objects. The test is helping me to design it. So that's why we have this thing called call customer request cache, and it helps me to name it as opposed to what we usually do, which is like call X because we haven't named it yet. And then we never get back to changing it from X. And then 2 years from now, somebody said, why are we calling this X? Those of you who know code know what I'm talking about. And then this last part is the expectations, which in testing we assert something. We say, does this thing equal this thing? If this thing equals this thing, our test pass. That's what this code is. You all can read it. You're humans. I know some of you just want to blank it out because you're like, code, oh my God. We're saying, does the expected account balance equal the actual account balance? And if this is not true, we failed the test. This is coming directly from the human readable English. I can almost read this code in human readable English, right? It tells me that I have a property called expected account balance, and it tells me that I should have an object called account that has a property called balance. It is helping me to write my objects, to write my code. This is why it's so powerful. Why everybody doesn't do it, I don't know. Did I dispense the cash? Here's another object, another property, right? Cash dispensed. Is that true or is it false? Card returned. Is it true? Is it false? So the BDD scenario, which is a test in human readable English, has now allowed me to write a test in code, and I can tie the two together with comments. Step 3 is to use a tool. I'm not going to go too much into it because again, this is for a technical audience. I know some of you aren't technical, and some of you are just, oh my God, we'll never get through this. There are tools out there. The one that I like best is called Cucumber, but there is not a programming language out there that does not have a BDD tool. So if your developers say, oh, no, we're doing blah, 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 there's no tool for it. No, BS. And because I've worked with all of them. Because that's the one thing when I work with developers, and I love my developers, but if they're resistant to something, they'll come up with all kinds of fun reasons, like all people do, of why we won't do it. And what I'll do is say, oh, you mean there isn't one for Python? No, it's called Lettuce. And I've used it before. And I'm really bad at writing code. So if I can do it, imagine what you could do. That's what I always tell them, right? So what it does is you take your scenarios and it uses regular expressions. That's what this is showing you to stub out some code. It makes it actually easier if you start using a tool. It stubs out some of the code for you. And again, if you don't just look at the code, it doesn't make any sense, but you can see that's what it's doing. So in this particular one is a login scenario. And you can see it says, you know, navigate to the login page, enter the username and password, and then, you know, if it's successful, you move on to the next thing. So what it looks like in code, for those of you who care, I'm going to go through this briefly, is this. We're basically going to call something called a driver, and that driver is for Firefox. So we're going to test it in Firefox, and we're going to navigate to a login page. We're going to enter a username and password programmatically, and then we're going to send it. And then we'll test it, right? When we test it, it looks like this. It will tell us how many scenarios are run and how many have passed. That's not very human readable English. So what it does, the tool gives you a very simple graphical user interface, which helps us even more. So this is the example of pagination. And here's the interesting thing about it. As you read this, it's in human readable English. Now, it's not in code. So you all, even if you're not code people, you can read this. It says, given the products page setting is set to 20 and there's a category with 30 products. When I view the category, then I should see 20 products when I click on page 2, right? That's, I set my pagination to 20, whatever. You can see though that, oh, I'm sorry. It says when I click on page 2, I should see five products or something like that, whatever it is. You can see where it failed. It says I should have had 5 products, but I had 10. This test failed. In human readable English. It tells me exactly where the test failed. It highlights the line. So it makes it very easy for me to backtrack, as I was telling you with the SAP example or whoever it was that we were working with third party. It tells me exactly where the problem is. Isn't that a great thing? When you have instrumentation on your system that tells you when you have a problem, exactly where the problem is, right? You with me? There are tests. You could take these tests, you can put them into a big test suite. I'm just showing that for people who care, which is probably even fewer and fewer people. So I'm going to get to the end. Here's some links. For those of you interested, I will post this presentation. You can look at some of the links. I do have to say one thing. If you're going to do a Google search for BDD, don't just search for BDD. Now, some of you are going to do this, even though I've warned you. Don't do it because you're curious. Don't do it because I've warned you. That's the opposite effect. I think it's called the Streisand effect, where you warn people not to do something so they do it more because, you know, we're people. You know that story, Barbra Streisand? They were like, don't buy Barbra Streisand's record for some reason or something like that. And everybody bought her a record because they were told not to. Humans are funny, aren't they? Don't look at it. Because there's one thing I can tell you from experience, you cannot unsee certain things, and these are things you do not wish to see. It stands for body dysmorphic disorder. It is a serious psychological disorder. You will probably end up with some pictures that you do not want to see. Once you see them, you cannot unsee them. I still have trouble sleeping. There's some helpful links, okay? Good enough. That's BDD. That's how in software development, we can easily, again, this asymmetric payoff, we can easily do some small changes to our input and get some great benefits on the backside, on the output, because we live in a complex system. It is, as I said, the closest thing to a silver bullet in software development that I've ever seen. When used properly, of course. So I want to talk briefly, hopefully we'll get through this. I actually promised the Reinertsen book, but I forgot we had this small presentation. It shouldn't take us too long. I want to talk a little bit about technical debt, what I refer to as the high cost to low cost software development. When we don't understand systems, I'm going to talk a lot about systems. When we don't understand systems, sometimes we make funny decisions. And one of them, as I said before, is we have a tendency to believe that our software is made up of features and that's what people really want. But the science tells us that that's not really what people want, because they might say they want them, but they don't use them. You ever run into that? That's really annoying. oh, we got to have this, blah, blah, blah. If we don't have this, the world will end and the Earth will start spinning in the opposite direction and only Superman can save us. And then you deliver it and nobody uses it, right? That's sales speak before my sales numbers are down, but it's not my fault. That's how that works. If only the product had this, I could sell tons of it. Now that they have this, they're not selling tons of it, but they probably already moved on to their next job. Anyway, sorry. I digress. What is technical debt? I want to talk about technical debt. Again, this is a little bit more technical, but it's not all technical because you'll have something like this in what you're doing. It's basically when we cut corners, sometimes referred to as design debt or code debt. It was coined by Ward Cunningham. I say this all the time. It didn't invent the wiki or had something to do with the invention of the wiki. Because whatever I say, it's always wrong. So I know he had something to do with the invention of the wiki. Somebody will put it in the chat, I'm sure. He says, basically, we incur technical debt when we don't do things the right way because we want to do, usually because we want to do them fast, because the business comes to us and says, if we don't have this feature by next week, we're going to all die. And so we do it as quickly as possible. We slapdash it together, right? We've all done that before. We use, baling wire and gum to fix something because we just don't have the time. This is the technical equivalent. It's like financial debt, and but it's a metaphor. So, don't take it too serious. It's just a metaphor. It's basically saying if you don't do things right, it's like saying, I'm going to pay it later. I'm going to fix it later. And then more and more stuff keeps piling up and then you pay interest on it. Just like regular debt. And the interest we pay is that it becomes harder and harder because the code becomes worse and worse over time because we haven't actually done the right thing up front. As it gets worse and worse, and it becomes harder and harder to make changes. So when the business comes to you, as I've said before, and they say, well, we just need to add this button to this page, and then development comes back and says, well, that will take a month or 2 months or whatever. Why? Because the system is so brittle now because we've incurred so much technical debt that nobody wants to do anything with the existing code. Trust me. Why does it happen? Business pressure. We don't understand what we're doing. This is how I would create technical debt in the past, right? My idea of programming when I was a programmer, I even own my own business doing programming. My apologies to my clients. I didn't charge them too much, so they probably got away with a pretty decent deal. But my job was the copying and pasting from Stack Overflow. That's how I programmed. I just didn't understand. There's something called loosely coupled components, and this is really important because this allows the flexibility, the agility to make changes. A tightly coupled component would be as if you had a car, and in order to change your battery, you had to take out the transmission and all 4 wheels, right? Cars are loosely coupled components. I can take out one piece and I can replace it. Same happens in software development, but you can write your software in such a way that everything is kind of tied in together. So if I pull one piece, the whole thing comes crashing down. That's tightly coupled code. I want loosely coupled code, just like a car, so I can take pieces and I can change them out without screwing up the entire vehicle. Lack of testing. This whole BDD, TDD thing, if you don't have a test suite, you've created technical debt. That's probably because of a lack of process and understanding. It's amazing how many people are taught how to code, but not taught how to test and do automated testing. Lack of documentation is also part of technical debt. Lack of collaboration. Parallel development. How many different groups do you have in your organization right now that are figuring out the process of logging in? That's why you have now these single sign-on vendors, single sign-on as a service. Because you had back in the bad old days, you had 10 different places within the organization trying to figure out how to sign on to a product. You don't need that. That should be plug and play, loosely coupled component. Delayed refactoring. I know there's a problem, but I'm not fixing it. I don't have standards. You should, if you're doing code, you should have some coding standards. And the reason that you have these standards, it's basically say, let's all agree that this is a good thing to do. It's not best practices, because I don't like the term best practices. This is what we agree on. It's kind of like driving. Sometimes it's like driving on the right-hand side of the road. Doesn't matter whether you drive on the right or the left, as far as I'm concerned, but you all need to drive on the same side of the road, because what happens if you don't? Right? That's what standards are for in some cases. Doesn't mean that they're the perfect standard. It doesn't mean that they're even the best standard. It just means that we agree to do these things, because if we don't, we're not going to be safe. We're going to cause problems. Lack of knowledge. That's a big one. We don't know what we don't know. Always reminds me of Rummy's 4 quadrants, right? The unknown unknowns. I call them Rummy. Martin Fowler put the quadrants together, and I remember on day one I told you, if you want to be famous in the world of consulting, you do 2 things. You invent quadrants and you write books. So Martin Fowler had created his. There's different types of technical debt. There's reckless, prudent, deliberate, and inadvertent. It makes up a quadrant. Basically, reckless and deliberate is, people who, I don't care. I'm doing it crappy, but I don't really care. Prudent and deliberate is, I know I'm cutting corners, but I have to, and I'm going to take care of it when the time comes, right? So reckless and deliberate is like somebody who has a credit card and never expects to pay it off, right? If we're using the financial metaphor, I'm just going to go buy a bunch of stuff and then I just declare bankruptcy. Fine. 7 years from now, I do it again. Prudent, deliberate is, I really need to have this thing, but I don't have the money for it today. So I'm going to put it on my card, but I'm going to pay the card off at the end of the month when I do have money, right? I'm not going to let it accrue, strong arm type interest that credit card companies charge. The reckless and inadvertent is, I just don't know. What you mean? I had to pay this back? I didn't know. I just thought it was free, kind of like the Blues Brothers when the free beer scene at the bar. Anybody watch? Never mind. Inadvertent and prudent is where I usually end up. We built this product. We didn't know what the heck we were doing, but now we've got a huge market share and we figured out, hey, we didn't really do it the way we should have done it, right? We messed up early on. Now we know better. We should start fixing it. We know better, right? So anyways, that's not all technical debt is bad. How many people are lucky enough? This is Bay Area, so this is a good loaded question, because if you raise your hand, I want to be your friend. How many people in the Bay Area are lucky enough or anywhere to own a home, right? Raise your hand. How many, keep your hands up if you paid cash and you own it completely? Because I want to be your friend. Because housing here is crazy, right? No, what you did is you went down to the bank. What'd the bank do? The bank gave you a loan, right? That's debt. Pretty good debt, though. I mean, owning a home is a good deal. One, I get to write off the interest. I get equity. You buy a house in California for $1 million today, it's worth $2 million next week. I get equity. It's a good investment. And sometimes technical debt is a good investment, but you have to go into it with your eyes open, right? You don't sign a mortgage and say, oh, you mean I had to pay monthly? I thought I was getting it for free. All technical debt has consequences. All debt has consequences. You're going to have to pay interest, and you're not just pay principal. They're going to charge you interest. And if anybody's looked at your mortgage statement, it's a lot over the years, right? How big is the problem? 6 years ago, I've been doing this presentation. It amazes me because I've been doing this presentation so long. I was doing it before 2015 because this was a projection. I don't know what the actual number was. $1 trillion. It's a lot of technical debt out there. I worked at one place I'm going to talk about a little bit where the technical debt, we did an estimation of technical debt, and it was almost exactly the yearly budget for their whole entire IT department. This was a huge company. Basically, if they did nothing in their entire IT department but fix the debt, pay down the debt, right? It's kind of like a national debt thing. That's how big it was. It would take an entire year. If you're writing code, you can actually estimate it by lines of code. So if you're an average company and you have 1,000 lines of code, I'd multiply that by $3.61, and I'd tell you that that's about probably what you have in technical debt. That's an average. It's more for Java. And the reason I put that in there is I worked, years ago, I worked primarily with people who wrote Java. And the reason that there's more technical debt with Java is complicated, but part of it is it's such a language that has such flexibility, but because of the flexibility of what you can do, you can also do a lot of things wrong, right? It's kind of like the problem with the paradox of choice. If you have a lot of choices, the odds of you getting the right choice go down, if there is a right choice or an optimal choice. That's just the principle. What's the interest? What do we pay every day, even if we don't pay down the principal of this debt? Well, one, everything slows down. Any enhancements that you need to make, this is a study from MIT. So this isn't just Larry, throwing some BS numbers around. This is a study that was done at MIT on some organizations. Your developer productivity decreases by up to 50%, meaning that if it was going to cost you $1 million and take a year, it's going to cost you $2 million in 2 years. It's going to slow you way down, which increases your cost of delay, which we're going to talk about later. Your defect density increases. When you're working with code that is hard to read, we're going back to what we said about BDD. If you're working with code that's poorly written, that has a lot of technical debt, you're going to create defects. So here's the one that surprised me. Remember I told you that developers' average tenure in the Bay Area is about 2 years, which is a lot of turnover. The worse the code is, the less they want to work on it. You with me? And your turnover increases. And the number that they found is up to 10 times more. And that's really expensive because nobody wants to work with crappy code. Make sense? That was the one that surprised me. The other two are pretty, intuitive. This is really surprising. It's a silent killer. I myself have hypertension. You can't see it, right? But I could blow a gasket at any time if I don't take my medication. It's a silent killer. The interesting thing is we usually track what is easy to track. We measure what's easy to measure. This is usually hard to measure, so we don't pay attention to it. Isn't that interesting? But now here's the fun things though, is we can now. Just like we can with blood pressure. We can measure blood pressure. We use a sphygmometer. We can start to measure technical debt because we have tools for that. It's called static code analysis. It's basically, we take a piece of software, we point it at your code, and it tells us all the things that are wrong with your code. Static code analysis. Sonar Cube is the one that I recommend because it's written for all the different programming languages. So you point it there and it shows you where your problems are. It shows you where your technical debt is. There's another thing that's interesting about this because it's not just technical debt. How do I quantify it? Not just what is it? Well, there's this thing called scale, SQALE. And what scale does is it takes and it says, okay, you have these problems with your code. It would take X number of hours for the average developer to fix these problems, right? And if you know how much it costs you per hour per developer, which is easy enough, it's called a landed cost. And I can multiply that by the number of hours to fix the code. And I have a number now, an estimate of how much technical debt in financial terms, in dollars and cents, I have, right? This is how we went about estimating the technical debt at this place I was talking about, is we were able to point a static code analysis tool to their code. We were able to find the things that were, problematic about it, and we were able to say, okay, it would take developers X number of hours to fix these things if we were to fix everything, and then we multiplied it by how much we pay each developer. So you can actually quantify it in terms of dollars and cents. So that's really important. So this is a thought experiment, but it's based on some real numbers. If I'm going to write some code, I have different strategies I can employ. I can do what I would consider an average cost strategy, a low cost strategy, and that low cost strategy is usually offshore strategy, China, India, Russia, something like that, where I'm paying less per hour per line of code. And then I could do what I would consider more high quality. I'm going to hire the best developers who understand things like test-driven development, which is very few, which we've already established. and I'm going to take these, the best, the cream of the crop, and I'm going to have them write code, but it's going to cost me more money. You all know how this movie works, right? Pay me now, pay me later. Sometimes you pay more for quality, and there's a reason you pay more for quality. Sometimes you just pay more and you're given the illusion that you've bought quality, because that's how our mind works, by the way. We assume when we pay more that we're actually getting more quality than we might be getting, because it's very hard to measure quality, but I've given you some ways to do it. The initial cost of the code in a low cost strategy is generally about a third. And I think that's not even as much now, because I think if we look back at the cost per developer per hour for places like India, back in the old days, it was probably about a third of what it would cost for a high cost developer in San Francisco Bay Area. I don't know if that still holds. It's probably still directionally correct. So I'm going to pay $250 per line of code, right? Makes sense, a third. But what's going to happen is I'm going to create more technical debt in most cases. Why? Well, it's not a given, but it's something that we see a lot of. Anybody who's worked with offshore will tell you that sometimes you don't get the same quality of code. And part of the reason is not because they're not quality developers, but a lot of times we're not communicating well with them. So I'm not making this is not a personal issue for me. I'm just trying to give you some guidance here. We're going to accrue more technical debt in our code, which is going to be problematic, because we're going to have to pay for it one way or another, either through the interest on the debt or the principal. And your maintenance costs are going to be higher because of the accrued technical debt. That's the interest. So that when you get through the other side and you look at the total cost of ownership, and you all understand this if you bought a car, right? There are differences in total cost of ownership. It's not just what you pay the day you buy the car. It's all the maintenance, the gas, etc. The total cost of ownership of a low cost strategy usually ends up being much, much higher per line of code than it does in a high quality or an average cost strategy. I just wanted to point that out. And I think you all get it. It's a thought experiment, because these are actual numbers, but they're based on all the assumptions that we talked about today, right? So the reason that we do the low cost strategy, I think, by the way, is we always have to look at when we're looking at systems, we look at incentives in the system. Somebody is incentivized to save money in the short run, and they're not going to be penalized in the long run. You know who's going to be penalized in the long run? It's going to be you if you're writing code. That's who's going to be penalized. So they're not paying for it. They're getting bonuses for it, but you're going to have to pay for it in the long run, because you're going to have to work with this code, right? And we pay with it every day, by the way, because we try to create, the worst thing sometimes we do is we try to create hybrid teams. And so when we create a hybrid team, the fun is that either one group of people gets severely, inconvenienced, or both groups get somewhat inconvenienced. Because it's really hard to work with somebody who's on a complete opposite schedule, even if you want to, right? Even if you wanted to. So it's not, again, I love all people, but it's not about that. It's about how do we create the best software? How are we optimal? And this is just not an optimal strategy. And that's my opinion. Anyway, that's it. I got through that fast, didn't I?